Good afternoon, fifth grade friends. Welcome back. I hope you've had a great week. I am Mrs. Matani, and today we're going to continue working on adding and subtracting fractions. Now we've kind of moved a little faster. We did coordinate grids last week, and then this week we went into fractions to make sure that all three essential concepts were covered by the time you all finish your online learning or your packets by next Friday, okay? But we'll continue to show videos. So I just wanted to let you know that we're moving a little faster just to make sure that everything is covered. The good thing about covering fractions now is that you've already done fractions, and so this is a really great way to review. But the reason we're covering fractions is because it's really important to have a great fraction foundation when you move on to sixth grade. So let's remember, our essential concept number 3 is fractions. Today we're going to look at adding and subtracting fractions with unlike denominators and solving word problems involving adding and subtracting fractions. Remember, we have some specific math terms to look at: denominator, numerator, equivalent fraction, and that's what you do when you try to find the lowest common multiple and denominator. You find an equivalent fraction for each fraction. Least common multiple, a number line. We're going to really look at number lines again today. Simplifying, what that means. The sum, you know what sum is, addition. The difference, subtraction. An estimate and a benchmark, which is really important to use, especially when you're unsure with how to add and subtract fractions. Mixed numbers and improper fractions. All right, so like I tell you every time, I check your exit ticket each time before we begin. So let's look at our exit ticket. Remember on Monday, if you were here with us on Monday, I had a student teacher with us. And this was the exit ticket that she gave you. Miss Gregory said to add 2/5 and 1/10. And then to subtract 7/8 and 5/16. I put a number line here with this one because I feel like this is really easy to look at and go ahead and add on the number line. And then I thought we would try using standard subtraction with this one. All right, so looking at 2/5 and 1/10, what was the lowest common multiple or denominator you chose for 5 and 10? Yeah, it should have been 10, right? And if you had 2/5, then 2/5 is equivalent to 4/10. So here on my number line, I started at 0, I have 1, and I broke that number line up into tenths. So 2/5 is the same thing as 4/10. And then all you had to do was add on 1/10. So your answer should have been 5/10. Is that what you got? All right, good, I hope so. The next one is 7/8 minus 5/16, or finding the difference between 7/8 and 5/16. Again, I feel like those denominators are really compatible. So when you think about 8 and 16, the lowest number that they have in common, the lowest multiple they have in common is 16, yeah. So 7/8 would turn into 14/16 because we multiplied by 2 to get that denominator. And if we multiply by 2 to get the denominator here, we must multiply by 2 with the numerator to get the numerator there. And then all you had to do was subtract 5/16. 14/16, taking away 5/16. What is the difference? 9/16. Now, this is as simple as I can go, 9/16. They don't have anything really in common that I can make this more simple to look at. But I want you to look up here at 5/10. Yes, 5/10 is correct. But is there a way that you could make that more simple to look at? Yeah, it's right smack dab halfway in the middle. So while 5/10 is the correct answer, I could make it more simple by saying 1/2. We always use the word simple or simplify and not reduce. Sometimes we get those confused, but let me tell you why we would not use reduced. Think about if you were going to go to the store and they had a really big sale on t-shirts. And they said this t-shirt right here was $6 and now the price is reduced to $4. $6 and $4 are very different. So if you reduce something, you change it completely. But if you make something more simple, it's not changed completely, it just looks a little bit different. 5/10, no matter what you do, will always be 1/2. So 5/10 simplified is 1/2, not reduced. That's one of my big pet peeves. We don't reduce fractions, we make them more simple. Okay? So as we go on today, you're going to hear me say that. I'm going to say, can we make this fraction more simple? Okay? All right, so now let's take a look at our brain teaser for today. This is going to be really important for you to be able to quickly choose common multiples for your denominators. So I want to give you just a few seconds. I want you to quickly look at this pair of fractions, 2/3 and 1/4, and find the lowest common denominator that they would have. I want you to look at 5/6 and 1/8 and tell me the lowest number they have in common. And then 3 and 8, 1/3 and 1/8. Go ahead and do that now. All right, so for 3 and 4, the lowest common denominator you should have found was 12. The lowest number that 3 and 4 have in common is 12. What about 6 and 8? That could be hard, that could be tough. I know 6 times 2 is 12 and 8 times 2 is 16. 6 times 3, 18. 8 times 3, what could it be? Yeah, it should be 24. And then the lowest common denominator for 8 and 3 is also 24. All right, so how'd you do? Pretty good? Okay. All right, now, here are our 3 strategies for adding fractions that I want to review with you today. Remember, no matter what we do, whether we choose to work on a number line, whether we choose to look at bar models, or do the standard way of adding fractions, we need to find a common denominator no matter what. So let's look at the first problem. It says, Maggie paddles her kayak 1/2 mile to an island. Then she paddles 4/5 mile to a beach. How far does Maggie paddle her kayak in all? All right, keywords, in all. So I know I'm going to find the sum, and we're going to be adding our fractions. Now, these are our 3 ways to do this. I'm first going to use the number line as an example. 1/2 mile. Then I see 4/5. So my denominators are 5 and 2. What is a common multiple for 5 and 2? Yeah, it's 10. So 1/2, if 10 is our denominator, and we just said this at our exit ticket, if 1/2 is 10 is our denominator, then what would be our numerator? 5/10. So here on my number line, I have a 0 and 1 whole. Here is 5/10. I'm going to plot it right there because 5/10 is also 1/2. Then I have 4/5. If 10 is my denominator, then remember 4/5 times 2 would be 8/10. So I'm going to add together 1/2 and, or 5/10, and 8/10. Here I am at 1/2. I'm going to jump on my number line 8/10 spaces, and let's see where I get. 1, 2, 3, 4, 5, 6, 7, 8. Notice what happened. When I added 8/10, I went over 1 whole because 5/10 is half and another 5/10 would be 1 whole, but I had to add 8/10. Is it okay to go over? Absolutely, because number lines are infinite. And so fractions are parts of wholes. So I could go over the 1 whole and continue going past, going up closer to 2 wholes, and that's fine. So when I started at 5/10 and moved 8/10 spaces, I got 1 3/10. But you know what? When I see 1 3/10, I also think of it like this. I'm going to write it and I want you to tell me what you see. I think of 1 3/10 like that. Think about that. Is 13/10 the same thing as 1 3/10? Let's see. I'm going to start at 0 and I'm going to count to this one and let's see if there's 13 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, there's 13 spaces. So 1 3/10 is equivalent, and it's the same thing as 13/10. And I can look at this and I can say, you know what? 10/10 is 1 whole. I've got 13 of them. I've got 13/10. So really, I have 1 whole and 3/10. So 13/10 is the same thing as 1 3/10. 1 whole, because 1 whole is 10/10, and then 3 more tenths. So number lines are really great to use when you're adding and subtracting fractions. Down here, you can see again that this is the standard way to do it, to find that common denominator. Again, 5/10 and 8/10 is 13/10. Don't let that scare you. 13 divided by 10 is 1 whole with 3 of the 10 parts left over, 1 3/10. We can also use bars. This bar right here shows the island in half, the half mile. And then it shows the beach, 4/5 mile. If you broke these bars into tenths, you would again see, and I'm going to try my best to break, that into a tenth there. And let's see what we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10 sections. I could do the same thing up here. This would be the halfway mark, 5/10. This is 8/10. And if I moved these boxes together, I would obviously go over 1 whole because there's only 2 spaces left here. So I'd go over 1 whole, 3 more spaces. So either of these strategies here work. You have to find the strategy that works best for you. For me personally, I love working on number lines. A lot of kids like to use standard, and that's okay. All right, so now let's take a look at this. We're going to now do standard strategy. But what we're going to do is we're going to estimate as well, because it's really important to find benchmarks. Benchmarking means finding where that fraction is closest to whole numbers so that we can add them in our heads. What is the sum of 7/6, which that is a number, and 5/8? What is 7/6? Think about that. Is it over a whole? Yeah, it is. So the estimate of 7/6, what is 1 whole? Well, 1 whole is 6/6, right? And it's just a little over that. So I'm going to say 7/6 is around 1 whole, okay? What about 5/8? When you think about 5/8, visualize eighths. What do you know about eighths? What's half of 8? Yeah, it's 4. So if 4 is half of 8, 5 is just a little over. So this is a little over 1, and this is a little over a half, right? So what do you think our estimated sum is going to be? A little over 1.5. Maybe close to 2, right? Because this is a little past 1, and this is a little past a half. So 1 added to a half would be 1.5, but both of these are a little over that. So I'm going to say it's going to be around 1.5. And if I see that already before I get started, then I have less chance of getting the wrong answer. So our estimated sum is going to be approximately, that's what that little shoop means, approximately 1.5, okay? So now let's look at our standard strategy, looking at 6 and 8. Can you list the multiples of 6 and 8? 6 times 1, 6 times 2, 6 times 3, 6 times 4, 8 times 1, 8 times 2, 8 times 3. What's 8 times 3? Yes? Good. 24, yeah. So there we go. And that was part of our brain teaser today, wasn't it? So now we know that the common denominator is 24. So now 7/6, 6 times 4. What is 7 times 4? 28. Now remember, we already knew that this was over 1 whole because this is 24 24ths would be 1 whole. So it's 28 24ths. And then what about 5/8? 8 times 3, so 5 times 3, I have 15 24ths. So now let's keep our common denominator of 24. What is 28 and 15? Well, I know 20 and 10 is 30. And then I know that 8 and 5 is 13. So what is 28 and 15? Is it 43? Yeah. Now, 43 24ths. Now, before we go any further, I want you to think about this right here. This is what's called an improper fraction, right? So we need to look at this, and let's just start thinking about numbers. I know 24 24ths is 1 whole. What would be 2 wholes? 48 24ths would be 2 wholes because 24 times 2 is 48. Do I have 48 24ths? No, I don't. I have 43 24ths. So I for sure have 1 whole. Well, is that our estimate? Our estimate said we'd have 1.5, a little over 1.5. So yeah, I for sure have 1 whole, and then I have to figure out what's left over. If I know that 1 whole is 24 24ths, and I take all those 24 24ths and I bring them together and make 1 whole, what would be left? I would subtract simply 43 and 24. What is the difference between 43 and 24? Yes, it's 19. So 1 and 19 24ths is our answer. Look at our estimate. Our estimate was a little over 1.5. Now I want you to think about something. 1 whole is here. Look at our denominator of 24. What is half of 24? It's 12. Yeah. Is this a little over half? Is this a little over 12 24ths? Yes. Because we estimated, we are correct. Sometimes numbers get confusing with fractions, especially something like 19 24ths. So it's really great to benchmark and estimate before you move on with the actual strategy so you know you're on the right track. All right, now let's practice with subtracting fractions. Again, looking here, we are going to choose a strategy that works for us. Maybe you like number lines. Maybe you like using fraction bars. And maybe you like the standard way of subtracting. We'll have to see what you choose. Whichever you choose, as long as you do it correctly, that's okay. Gavin has 2/3 pint of water left in his water bottle. He drinks half a pint. How much water is left in the bottle now? All right, we have a 3 and a 2 as our denominators. I want you to think first of a common number that they have. 3 times 1 is 3. 3 times 2 is 6. I'm going to go ahead and stop right there because I should already know as a 5th grader that 3 and 2 have 6 as the common denominator. But just in case, 2, 4, 6. There it is. Now, on my number line, what would 2/3 be equivalent to on my number line? 2/3, if 6 is the denominator, would be equivalent to 4/6. So I'm going to go ahead and plot that on my number line of 4/6. I'm taking away half. What is half of 6? 3, yeah. So is 1/2 the same thing as 3/6? Yes. If I take 3/6 away, 1, 2, 3/6 away, I get 1/6. Pretty easy. Again, estimating before can really help out. Thinking that 2/3 is close to a whole. Taking away definitely a half, you're going to have some left over, which is really just 1/6. So estimating and benchmarking can also help you. All right? What about this one with mixed numbers? Let's first estimate what we see. 5 and 4/5. When I think of 5 and 4/5, I think that's very, very close to what? 6. Yeah, because 5 and 5/5 would be 6. And then I think of 1 and 9/10. 1 and 9/10 is very close to 2 because 9/10 is close to 10/10, which is 1 whole. So now I have 6 minus 2. So the difference should be around 4. Maybe a little less than 4, maybe over 4. We'll have to see. What would be the common denominator? Obviously, it's going to be 10. Yeah. So if I make these both 10, this one already is, that's super simple. And if I write them up and down, I have 5 and 4/5, which would become 5 and 8/10. And I'm taking away 1 and 9/10. Uh-oh. What do you see? I see 8/10 here and 9/10 here. I can take 5 and 1. I can take 1 away from 5, but I can't take 9/10 away from 8/10. So what do? I have 5 holes here. That means I have 5 sets of 10/10 that I can get parts from. If I take an entire whole and give it to this fraction to help it out, that would be 10/10. So if I took 10/10 from 5 holes, that's 1 whole. What's 5 holes minus 10/10? It's 4 holes. And if I give those 10/10 to this fraction, it becomes 18/10. 4 and 18/10 is the same thing as 5 and 8/10. Now, can I subtract? Yes, I can. Looking at this problem, what would be your difference? Your difference should be 3 and 9/10. Now look at our estimate. Our estimate was 4. And that's 3 and 9/10. Aren't they close? Yes. All right, your exit ticket for this week, I want to do something a little bit different. I want you to write a subtraction equation with unlike fractions. They have unlike denominators. I want you, and it says brainstorm together, so you can do this with a parent, a guardian, or maybe a sibling. I want you to also draw a picture and illustrate your equivalent fractions, and then draw a picture to show everything. Remember, brain teasers or questions, give me a call or email. Thank you.